So in this module, I'd like to take some time to discuss iSCSI and the different pieces that makes up the iSCSI infrastructure. What I would like to do is to finish the theoretical part in this module. So in the next, we'll just get straight into our demonstration. For demonstration, since I don't have a physical SAN, I'll be configuring a virtual machine and to serve as our SAN. So I'll be configuring the Linux-based OS OpenFiler. I'll be configuring OpenFiler and Windows Server, both as our SAN. So you guys could have an idea how to configure both to use in your lab environment, for example. So I'll go ahead and deploy OpenFiler as an iSCSI target, and then briefly demonstrate setting up of Windows Server also as an iSCSI target. I'll also demonstrate setting up of NFS on OpenFiler and on Windows Server too. But we'll save that for the next module. So let's just go ahead and finish off the discussion on iSCSI shared storage here, and then in the next module we'll get straight into the demonstration. So what is iSCSI? iSCSI lets us deploy block-based storage without a fiber channel infrastructure. Okay, so it encapsulates SCSI control and data into TCP IP packets, which in turn are then encapsulated in our Ethernet frames. So with this infrastructure, TCP retransmission mechanism can be used in cases if we have drop packets or drop frames. Sorry. So in the iSCSI storage infrastructure, it is made up of the iSCSI initiator, which would be the ESXi host in our case, and the iSCSI target, which would be our iSCSI SAN. So let me just pull up my next slide here. iSCSI utilizes iSCSI qualified names, or IQN. This is used to identify both the target and the initiators. The IQN, these are very similar to worldwide name, or WWN, as used with fiber channel. So generally when we're setting up communication between our initiator, which would be our host, and our iSCSI target, we'd want to ensure that the initiator and the target, they are both on the same broadcast domain or subnet. So basically you won't have any routing involved from the initiator to the target. The LUNs that are on our iSCSI target, each would be represented as a separate storage volume, a storage volume from which we could then carve out our data store from. Okay, but we'll get into the demonstration of setting up the iSCSI target and then discovering our LUNs and then creating data stores for storing our virtual machines from that. We'll get into all of that before we finish our storage section. Also, there are two ways where we could discover, or how we could discover, our iSCSI target. We have both the static and the dynamic discovery method. Actually, I have a separate slide which will deal with this in a little bit. So let's move on from here. So next we have the different types of iSCSI connections. We have three different types here. We have our software initiator, and this is what we'll be using in our demonstration. We have the dependent hardware initiator and also the hardware initiator. Okay, so the software iSCSI initiator, this is built into the VM kernel, and it allows us to connect our host to the iSCSI target through our regular network adapters. Okay, so all of the iSCSI processing, this would be done in software, okay, by the VM kernel. So with software based iSCSI initiator, we are using iSCSI technology without sourcing any specialized hardware adapters in our ESXi host. All right. Next in the list there we have our dependent hardware iSCSI initiator. This generally is a standard network adapter that depends on the VM kernel for networking, but it also have your iSCSI offload functionality built into the card. So as the name suggests, the dependent hardware iSCSI initiator, it depends on VMware networking. So for this to work, we would need to set up networking for our iSCSI traffic, as well as to bind the adapter to a VM kernel iSCSI port. Alright, this is very similar with how you would configure the software iSCSI initiator. Finally, in the list there, we have our independent hardware iSCSI initiator. With this, the adapter would have its own networking and iSCSI offload capabilities built into the NIC. So it would not depend on the VM kernel for networking functionality, sorry. So basically the hardware would handle all the iSCSI traffic, network processing, and management traffic. As I mentioned previously, we have two methods for discovering the targets, or our iSCSI targets, on our iSCSI SAN. Firstly, we have static, and then we have our dynamic discovery. With static discovery, the initiator on our ESXi host, it does not perform the discovery, since the initiator would know in advance the targets that it needs to communicate with. Okay. With dynamic discovery, this is also called send targets discovery. The initiator sends send targets requests every time it's communicating with the iSCSI target. So the name and IP address are actually added automatically through the dynamic discovery process for the target. Okay, this is our final slide here. This is on multipathing with iSCSI. Okay, so multipathing basically can be defined as a system where our host is using multiple paths to access and manage a storage device. Alright, so in our demonstration, we will be configuring multipathing to our iSCSI storage device. So for this to occur, we would need to configure our networking so that each path uses only a single NIC to access that iSCSI storage. This would allow us to use our iSCSI deployment to scale across multiple NICs.